Hi! If you're watching this series, you certainly want to make a multiplayer game or just want to learn more about Photon Bolt. In this episode we will see the concept of states in Photon Bolt. At first we will talk about everything that we need to know about states. Next we'll go see some practical examples, and at the end I will give you some tools in order to make sure that your states are correctly made. At the core of Photon Bolt there is the concept called state. Using Bolt's state implementation, you define the network state of an entity as a template which includes properties for such things as transforms and many other built primitive types variables. In addition, you can implement protocol tokens as properties, which is essential in a way if you want to implement arbitrary data types as a state property. The power of Bolt state is that allow the user to sync network properties automatically and only when they change. In addition, state makes implementing late joining almost transparent. Whenever the owner of Bolt state change a property, Bolt will send the value to clients. If the user attach to the updated property any callbacks, they will be called at the update time. Each state property, like a float or transform, has a default value that cannot be changed. This value is set first when an entity is created. If a particular property value has not been changed from the default value, Bolt will not sync this property to any connection. State can also be extended with custom properties if the native ones are not enough. This is done using an implementation of a protocol token. Keep in mind that changing data inside the token will not trigger Bolt to send the property as changed. Bolt will only send the token if the token reference itself has been changed. This means that you need to reference another token to the state, or to set this token to null, or from null to a token. When a new connection joins the game, all entities will automatically sync to him. All change properties will also be synced to this player. Depending on the number of entities and properties, this could take a variable amount of time. Bolt will only send as many packets per second as it's set in the Bolt settings, so eventually all of the data will arrive on the client. This makes the implementation of late joining very simple. So in order to create states, we're gonna head to the Bolt asset window in Unity, and we're gonna right click on our screen and create a new state. This will open the Bolt editor, in which you will be able to add properties via this button right here, new property, and select the property name in here, or the property type in here. On this page you can see every types that are built in Bolt, and every parameter that they have is described inside this page. And if you want to remove, for example, a property, you only need to hit Ctrl or on your keyboard, and a cross will show up here, and you will be able to delete the property. Same for the state. Ctrl and click on the red cross. So, see who's back, the true real world, yay! In our true real world, what we need? We need 3 peers. One a server, and the 2 others clients. Basically it means that we have a dedicated server case. So here what we want to explain states, and in order to explain states I will explain you how to make a campfire simulator. Yeah, nice, no? So, let's see. As usual, we will have our peer, our client peer, which will demand to spawn a campfire, because he wants to spawn a campfire, because we are in a campfire simulator, and same for the other. So here we will have the campfires that will be owned by the server and controlled by the original peers that have spawned them. Our campfire is an entity, and this entity will have a state, otherwise you cannot spawn it. And this state will be the campfire state. How to determine what we give to our state? First, let's describe our campfire. It will have a static behavior. This means that it will burn straight forward for 10 hours. This burning process means that we can create an axis of time, which means that we'll have a progression, and this progression can be translated by the fuel amount. So mainly it's the progression of your fuel over time. Here we have basically a minimum and a maximum. The maximum means that we are at the beginning of our fire, and the minimum means that our fire is gone. So yeah, so we have time 0 and time n plus 1. And of course, in between we can have a time n somewhere on this axis. So basically this means that we will need to know the value of it whenever we are on the server. So our entity have a state, the campfire state, and as a player we can see it burning. This means that we have fuel on it, and this fuel is translated by a float that goes from a minimum of 0 to a maximum of 100. For example, our campfire will have a property that will be the property of type float named fuel, and to this property we will attach a callback. This callback will be named update fire amount, and it will be called on every client every time the value is changed. So yeah, it's pretty basic. The server side. As I said, the server owns both of the campfires. The client one controls only his campfire that he spawned. And so we see that the server continuously sends a change to its entity. So basically the entity, a script is changing the entity.state.fuel property, and each time it's changed, this means that the value has gone from a value A to a value B, it calls the callback. I need to say a little warning here. You need to know that if you do that on the server, the callback will be called more often than on the clients. Basically because the packet send is not related to the update. Basically it's that. So, and often we will send less packets than we have updates on our client or on our server. So yeah, the callback will be called on the server side, the callback will be called on the client one side, because he controls it, but it has nothing to do with the callback, and it will be called on the client 2 side, on the entity that have updated its state, and it will be updated on this entity in particular. And so what happened if we have a player that joins? Before syncing anything on the network, even if we don't send every frame an update of our fire, on the server side we'll have a call that will help our peer that joined the server to sync the states of every entity on the server. This means that basically if the value of her entity is not default, it will be updated on her client number 3. And by updated, I mean the callback attached to the property will be called. Simple as that. So it's very good to have a campfire simulator, but what if it's just a little feature in which gives us the permission to cook food? And this means that some food can be cooked only on some power of fires and other on lower, and etc. etc. So Let's see this case. So basically, we don't want to send the fuel update every frame because it's too big for our network, if only it's a tool for our player. So this means that we will need to change this logic. And in order to do that, let's redescribe and think about another thing. So we have the static behavior like always with a burn time of 10 hours, and here what we want at the end is the simplest case that we can imagine. Basically, we want to know as a client at what point our fire power is 0, we have no fire. If it's 3, we have a moderate fire, and if it's 5, it's a big fire. And the cook time and everything related to it will change. And of course, the visual of the campfire will change with it. So in order to do that, let's think how we can implement it. So if we have an implementation on a dedicated server, we will have a timer on this server, on this script that manage the fire, and this script will have a timer. This timer will help us to calculate the power by time, and each time we need to change the power from 5-4 and from 4 to 3 and etc, we will set the integer corresponding to the power on our state, and then every client will receive, of course, this change that will call the callback on each client and will help us to manage the fire visual and interactions. So yeah, basically it's everything I wanted to share with you in this episode. It's a very difficult episode because it have many things to learn, very basic but very dense, I think, for someone who begins. So yeah, next episode we will see advanced states, what states can be at the end with all that it gives to us. And yeah, so thank you for watching. Have a nice day. Remember to code every day, and of course, see you next time.